Hi children, welcome to 9th class digital lessons. So, subject is physical sciences and today we are going to discuss about the atoms and molecules part 2. Already in part 1 we discussed about the law of conservation of mass, law of constant proportions, Dalton's atomic theory, symbol of elements and how the molecules and compounds are formed. All these things are discussed in previous class, previous session. Okay. So, law of conservation of mass means what? Mass is neither be created nor be destroyed during a chemical reaction. And law of constant proportion means what? A given chemical compound always contains the same element combined in a fixed proportion by the mass. And Dalton's atomic theory explained that atom is neither be created nor be destroyed during a chemical reaction, and atom is part of the matter and which can take part in a chemical reaction. We discussed about the symbol of elements also. So, the symbol of elements is depends on the initial letter of the English name of element. In this session we are going to discuss about the atomicity. Atomicity means what? Atomicity is nothing but the number of atoms are present in a given molecule or in a given compound is known as its atomicity. What? Atomicity means what? The total number of atoms present in a given compound or in a given molecule is known as atomicity. For example, hydrogen chloride is there, HCl is there. In HCl, two atoms are there, one is hydrogen and another one is chlorine. Total number of atoms are 2. That is why the atomicity of hydrogen chloride is 2. In the same way, nitric acid is there. In nitric acid, one hydrogen atom is there, one nitrogen atom is there and 3 oxygen atoms are there. That is why total number of atoms are here 5. That is why the atomicity of nitric acid is 5. So, in the same way here few examples are there to explain the atomicity. So, a molecule of hydrogen is there. Hydrogen, in hydrogen molecule 2 hydrogen atoms are there. That is why the atomicity of hydrogen is 2 and it is called as diatomic molecule. Hydrogen is known as which kind of molecule? Diatomic molecule. Why? Because in H2 molecule 2 hydrogen atoms are there. In the same way chlorine is there. In chlorine 2 Cl atoms are there. That is why chlorine is also known as diatomic molecule. And few of the elements are there, they are having only one atom. Example, helium, argon and neon, krypton, xenon and radon. So, helium symbol is He, argon symbol is Ar. These elements are having only one atom. That is why these elements are called as monoatomic gases. These elements are known as monoatomic gases. Why? Because these elements are having only one kind of atom, only one atom only exists in these elements. That is why these are known as monoatomic. And few elements are having 3 atoms, supposed to be ozone is there. In ozone 3 oxygen atoms are there. That is why it is known as triatomic. For example, phosphorus is there. In phosphorus 4 p atoms are there. That is why it is called as tetraatomic. And sulfur is there. In sulfur 8 sulfur atoms are there. That is why it is called as octaatomic. So, observe the following table to know the atomicity of molecules of few elements, and you see here 3 columns are there. First column is name of the element and second column is formula and third column is atomicity. So, first you see here in name of the element argon. Argon is a inert gas and symbol of argon is Ar and it is a monoatomic. Why? Because in argon only one argon atom is there. In the same way second element is helium. Helium symbol is He and its atomicity is monoatomic. Why? Because only one atom is present. Sodium symbol is Na and it is also called as monoatomic. Why? Because only one sodium atom is there. Iron Latin name is ferrum. that is why its symbol is Fe, and it is also known as monoatomic because only one iron atom is present. Aluminium, aluminium symbol is Al, and it is also known as monoatomic because only one aluminium atom is present. Copper, symbol of copper is Cu, and it is also known as monoatomic. Next example, hydrogen. Hydrogen formula is H2. Here two hydrogen atoms are there, that is why it is known as diatomic molecule. Oxygen, oxygen exists as a O2. So, O2 means two oxygen atoms are there, that is why oxygen also diatomic molecule. Nitrogen, nitrogen formula is N2. Here also two nitrogen atoms are there, that is why it is also diatomic. Chlorine, chlorine symbol is Cl2, and here two Cl atoms are there, that is why it is also known as diatomic molecule. Ozone, in ozone three oxygen atoms are there and its formula is O3, that is why it is called as triatomic. Phosphorus, phosphorus formula is P4, here 4 phosphorus atoms are present, that is why it is known as tetraatomic. Sulfur, sulfur symbol is S8, here 8 sulfur atoms are there, that is why it is known as octaatomic. So, next important concept is valency. So, this valency means what? Valency is nothing but each and every element try to combine with each other and forms molecules or compounds. Each and every element. Why these elements are combined with each other? Because they are trying to get the stability. They maybe lose the electrons, or they maybe gains the electrons, or they maybe share the electrons. So, this is totally depends on the valency. Valency means what? Valency is nothing but combining capacity of an element. Valency is nothing but combining capacity of an element. Each and every element can combine with the other elements to form the molecule or to form the compounds. For example, hydrogen is there. Hydrogen combines with one element, that may be similar element or that may be different element. Suppose to be hydrogen is there. If two hydrogen atoms are combined with each other, then forms H2 molecule. If hydrogen combines with Cl atom, then it forms HCl molecule. If hydrogen combines with oxygen, then it forms H2O molecule. So, here combining capacity is nothing but valency. Combining capacity of an element is known as its valency, and this valency is depends on the outermost electronic configuration of an element. This valency is different for different elements. For example, hydrogen is there. So, valency of hydrogen is 1, means hydrogen combines with one element. Oxygen is there. Oxygen valency is 2. Oxygen element can combine with the two other elements or two similar elements. So, you see here valencies of some elements. Here two columns are there, one is element and another one is valency. So, in element column first one is helium. Helium valency is 0. That means helium does not combine with any other element. Helium is already stable because helium gas is considered as a inert gas. It is already stable. Each and every element try to get the stability. So, here helium is already stable, that is why it is not combined with any other element. So, that is why its valency is 0. And next element is hydrogen. Hydrogen valency is 1. Hydrogen combines with another one element, that may be similar atom or that may be any other element, that may be oxygen, that may be nitrogen, that may be carbon or that may be silicon, whatever it may be. In the same way, next element is fluorine, and fluorine valency is 1. That means fluorine combines with the one element. Chlorine, chlorine valency also 1. So, in the same way chlorine also combined with the another one element. Oxygen, oxygen valency is 2. So, oxygen also combined with two elements, that may be two similar atoms or maybe two different atoms. If two similar atoms, if oxygen combined with the remaining same two oxygen atoms, then it forms ozone. If it combined with the two other atoms, means two hydrogen atoms, then it forms water molecule. So, next one nitrogen. Nitrogen valency is 3. Nitrogen is combined with the 3 other elements. For example, nitrogen forms ammonia. So, in ammonia, nitrogen combines with the 3 hydrogen atoms and it forms NH3 molecule. For example, another one example, NCl3 molecule. In NCl3 molecule, nitrogen combines with the 3 Cl atoms and it forms NCl3 molecule. And next one, carbon. Carbon valency is 4. That means what? Carbon is combined with the 4 other elements. So, if supposed to be carbon is combined with the 4 hydrogen atoms, then it forms CH4 molecule. So, this CH4 molecule is called as methane gas. So, next important topic is ions. Why ions are formed? What is the necessity, the formation of ions? Because already we discussed that each and every element try to get the stability by the sharing of electrons or by the transferring of electrons, means by the losing of electrons and gaining of electrons. So, in this way, by the transferring of electrons, here ions are formed by the transferring of electrons. So, each and every elements try to get the stability by the sharing or by the transferring of electrons. So, which kind of elements transfers the electrons? Here two kind of elements are there. So, one is metals and another one is non-metals. So, in between metals and non-metals, transferring of electrons takes place. Metals lose the electrons and non-metals gains the electrons. Here ions are formed by the metals and non-metals. So, here two kind of ions are there. One is positive ion and another one is negative ion. Positively charged ions are known as cation and negatively charged ions are known as anion. So, how the positively charged ions are formed? By the losing of electrons. If any metal lose the electron, then it forms positive charge. If positive charge is formed, then it is known as cation. For example, sodium is there. Sodium loses its one electron to get the stability. That means what? It loses one electron. So, one positive charge is developed on sodium. So, Na plus ion. So, that Na plus ion is called as cation. In a same way, another one element is there, that is non-metal chlorine. Chlorine accepts the one electron to get the stability. That means what? It is accepted one electron. That is why here negative charge is developed. So, if negative charge is developed on any atom, then it is called as anion. So, here one electron is accepted by the chlorine, that is why it forms Cl minus ion. These oppositely charged ions are combined with each other and forms a stable compound. So, ions may be charged independent atoms or group of atoms that have a net charge on them. Hence, ions are charged particles. So, now you observe here one table, some common simple and polyatomic ions are there. So, in first column net charge is there and second column cation and third column cation symbol is there and fourth column anion is there and fifth column anion symbol is there. So, here net charge is there. In first column net charge is there. So, in that 1 unit, 2 units, 3 units, that means what? 1 unit, 2 units, 3 units means what? It is a charge. What? It is charge. 1 unit means that may be plus 1 or that may be minus 1. Plus 1 means what? Losing of 1 electron. Minus 1 means what? Gaining of 1 electron. Then 2 units means what? 2 units means plus 2 or minus 2. Plus 2 means losing of 2 electrons and minus 2 means gaining of 2 electrons. 3 units means in 3 units two kind of ions are formed, one is plus 3 and another one is minus 3. So, plus 3 when it is formed? By the losing of 3 electrons. If 3 electrons are lost, then plus 3 charge is developed. If 3 electrons are gained, then minus 3 charge is developed. So, here some examples are there. Cation is there. In cation, first one is hydrogen. Hydrogen forms cation and its symbol is H plus. Sodium symbol is Na plus ion. Potassium forms K plus ion. Silver loses 1 electron and forms Ag plus ion. And copper loses its 1 electron and forms Cu plus ion. Ammonium group loses its 1 electron and forms ammonium plus ion, means NH4 plus ion. In a same way, anion. In case of anion, hydrogen accepts 1 electron and forms anion, and that anion name is hydride. Hydride symbol is H minus. Next, chloride. Chlorine accepts 1 electron and forms Cl minus ion. Next one, bromide. Bromine accepts 1 electron, forms Br minus. Iodine accepts 1 electron and forms I minus ion. Hydroxide, OH group accepts 1 electron and forms OH minus ion. So, it is about the net charge 1 unit, and next one 2 units. So, in case of 2 units means are losing of 2 electrons or gaining of 2 electrons. So, magnesium. So, magnesium loses 2 electrons and forms Mg plus 2 ion. Calcium. Calcium loses its 2 electrons and forms Ca plus 2 ion. Zinc. Zinc loses 2 electrons and forms Zn plus 2 ion. Copper. Copper loses 2 electrons and forms Cu plus 2 ion. Iron. Iron loses 2 electrons and forms Fe plus 2 ion. And few examples for anions. Oxygen. Oxygen accepts 2 electrons and forms oxide ion, that is O minus 2. Sulfur. Sulfur accepts 2 electrons and forms sulfide ion, and its symbol is S minus 2. Sulfate. Sulfate accepts 2 electrons and forms SO4 minus 2 ion. Carbonate. Carbonate accepts 2 electrons and forms CO3 minus 2 ion. Dichromate. Dichromate also accepts 2 electrons and forms Cr2O7 minus 2. Now, net charge 3 units. Examples for cations. Aluminium. Aluminium loses 3 electrons and it forms Al plus 3 ion. Iron. Iron loses 3 electrons and forms Fe plus 3 ion. And examples for anion. Nitrogen gains 3 electrons and it forms N minus 3 ion. Phosphate. Phosphate gains 3 electrons and forms PO4 minus 3 ion. So, valency of an ion is equal to magnitude of its charge. For example, valency of chloride is Cl minus, that is equal to 1. Valency of sulfate ion is 2. SO4 minus 2 charge is there. On SO4 group minus 2 charge is there. So, that is the valency of sulfate group. Next important topic is, so atomic mass. The number of times, atomic mass means the number of times one atom of a given element is heavier than the 1/12th part of the atomic mass of carbon 12 is called as its atomic mass. So, you see here in carbon 12 parts are there. So, in that 1/12th part, for example, hydrogen is there. How we can find out the atomic mass, how we can calculate the atomic mass of hydrogen means how many times the atomic mass of hydrogen is heavier than the 1/12th part of the atomic mass of the carbon 12. That is known as atomic mass of hydrogen. It is relative mass ratio here. So, one atomic mass unit is defined as the mass exactly 1/12th atomic mass of carbon 12 isotope. According to latest IUPAC, IUPAC means IUPAC, International Union Pure and Applied Chemistry. According to IUPAC, AMU has been replaced by U, which is known as unified mass. So, in this table atomic masses of few elements are there. Hydrogen element is there. Hydrogen atomic mass is 1, unified mass. Next element carbon. Carbon atomic mass is 12, unified mass. Nitrogen atomic mass is 14, unified mass. Oxygen atomic mass is 16, U. Sodium atomic mass is 23, U. Magnesium atomic mass is 24, U. Aluminium atomic mass is 27, U. Phosphorus atomic mass is 31, U. Sulfur atomic mass is 32, U. Chlorine atomic mass is 35.5, U. Potassium atomic mass is 39, U. Calcium atomic mass is 40, U. So, now chemical formula of the compounds. So, how we can write the chemical formula of the compounds? So, first of all we have to see, so which kind of atoms are present in a given molecule. We have to see how many kind of, means how many number of atoms are there. It is very, very important. So, for example, oxygen molecule is there. Then how we can write the symbol of oxygen means, you first of all you have to identify that in how many oxygen atoms are there. 2 oxygen atoms are there. First of all you have to write the symbol of oxygen, that is O, and next one you have to write subscript. How we can write symbol of oxygen is O2 means, so in O2 molecule here first of all we have to write the symbol of oxygen O, then we have to write the number of oxygen atom. In oxygen molecule 2 oxygen atoms are there, so we have to write 2 as a subscript, that is O2. So, we must see the elements present in a molecule of the compound. Second, we must see the number of atoms of each element present in that molecule. If the molecule of substance contains only one atom, subscript need not be written in the formula. If two atoms of hydrogen and one atoms of oxygen are present in a molecule of water, its formula is H2O. Water molecule formula is H2O. In H2O, two hydrogen atoms are there and one oxygen atom is there. So, symbol of hydrogen is H. So, first of all we have to write the symbol, then we have to write subscript, that is 2, H2, and next element is oxygen and symbol of oxygen is O. So, that is why H2O. It is the chemical formula of water. A molecule of carbon dioxide CO2 contains one atom of carbon and two atoms of oxygen. A molecule of carbon monoxide contains one atom of carbon and one atom of oxygen. You see here, carbon dioxide molecule is there and carbon monoxide molecule is there. In carbon dioxide molecule, one carbon atom is there and two oxygen atoms are there. So, carbon symbol is C and oxygen symbol is O, but here only one carbon atom is there. So, there is no need to write the subscripts. So, that is why simply you have to write C, but in case of carbon dioxide molecule, two oxygen atoms are there. So, that is why CO2, it is the formula of CO2, but in case of carbon monoxide, one carbon is there and one oxygen atom is there. So, just we have to write the symbol of carbon and symbol of oxygen, that is CO. It is known as the symbol of carbon monoxide. Writing chemical formula of compounds in crisscross method by using valency. Write the symbols of each atom or group of atoms side by side. Usually the cation first and anion next. For example, sodium carbonate. If you consider the example sodium carbonate, in sodium carbonate cation is sodium and anion is carbonate. So, sodium symbol is Na and carbonate symbol is CO3. So, first of all we have to write the cation, then next anion. So, Na CO3, then next write the valency of each atom or group of atoms, the top of its symbol. So, at the top of the symbol we have to write the valency of sodium and valency of CO3. Valency of sodium is 1. So, that is why Na1. Next important point, divide the valency numbers by their highest common factor if any to get the simple ratio. Here if any common factor is there, then we have to divide the valency numbers, but there is no dividing number is there, that is why we have to simply write Na1 CO3 2. Interchange the valency and write the numbers as the subscript to right side of the constituents as their subscripts. Then formula of sodium carbonate is Na2CO3. So, if any constituent receives the number 1, ignore it while writing the formula. If constituent has more than one atom, enclose it within brackets. If it carries 2 or more, mention as a subscript. Some other examples are there. Hydrogen chloride. First one, formula of hydrogen chloride. In hydrogen chloride, two atoms are there. One is H, means one hydrogen atom is there, and another one is chlorine. So, hydrogen symbol is H and chlorine symbol is Cl, and valency of hydrogen is 1. Now, you apply the crisscross method, then we get the formula of hydrogen chloride, that is HCl. And second example, formula of magnesium chloride. In magnesium chloride, two kind of atoms are there. One is magnesium and another one is chlorine. Magnesium is a metal and chlorine is a non-metal. So, magnesium forms cation and chlorine forms anion. So, first we have to write magnesium, then we have to write chlorine. So, magnesium valency is 2. So, we have to write at the top of the magnesium 2, and Cl valency is 1. At the top of the chlorine atom we have to write 1. It is the valency of chlorine. Then apply the crisscross method, then we get the formula of magnesium chloride, that is MgCl2. And third example, formula of calcium oxide. So, in calcium oxide, two elements are there. One is calcium and another one is oxygen. So, calcium symbol is Ca and oxide symbol is O. So, valency of calcium is 2. So, at the top of the calcium symbol we have to write 2, and at the top of the oxygen we have to write 2, because the valency of oxygen also 2. Divide these two valencies by the highest common factor, that is 2, then we get what? Ca1 and O1, because here 2 is there. So, these 2 are divided by the highest common factor, that is 2. That is why Ca1 and O1. Now, you apply the crisscross method, then we get the formula of calcium oxide, that is CaO. Chemical formula of some other compounds. You see here one table is there. In the table, first column is compound and second column is formula. In first column, copper sulphate, formula of copper sulphate is CuSO4. Second compound, sodium hydroxide, formula of sodium hydroxide is NaOH. And third compound, sulfuric acid, formula of sulfuric acid is H2SO4. Potassium dichromate, formula of potassium dichromate is K2Cr2O7. Next compound, potassium permanganate, and its formula is KMnO4. Next compound, sodium carbonate, and its formula is Na2CO3. Next compound, sodium bicarbonate or sodium hydrogen carbonate, and its formula is NaHCO3. So, next one is molecular mass. Molecular mass means the total atomic masses of all atoms in a given molecule or in a given chemical compound, that is known as molecular mass. For example, water is there. In water, 2 hydrogen atoms are there and 1 oxygen atom is there. So, the total atomic mass of 2 hydrogen atoms and 1 oxygen atom, that is known as molecular mass of water molecule. For example, in H2O 2 hydrogen atoms are there. So, what is the atomic mass of hydrogen? Atomic mass of hydrogen is 1 U. So, here how many hydrogen atoms are there? 2. That is why the atomic mass of 2 hydrogen atoms is 2 unified mass. And in water molecule, 1 oxygen atom is there. So, oxygen atomic mass is 16 U. If you add these 2 atomic masses of these 2 elements, then we get the molecular mass, that is 2 plus 16, that is 18 U. So, the molecular mass of water is 18 U. So, here one example is given that calculate the molecular mass of H2SO4. So, in case of H2SO4, you see here 3 kind of atoms are there. One is hydrogen, second one is sulfur, and third one is oxygen. So, hydrogen atomic mass is 1 U, sulfur atomic mass is 32 U, oxygen atomic mass is 16 U. So, how many hydrogen atoms are there? So, total mass of atomic mass of hydrogen is 2 U, and only 1 sulfur atom is there. So, sulfur atomic mass is 32. Here 4 oxygen atoms are there. So, for 1 oxygen atom atomic mass is 16, but here 4 oxygen atoms are there. That is why 4 oxygen atomic mass is 64. So, solution: 2 into atomic mass of hydrogen plus 1 into atomic mass of sulfur plus 4 into atomic mass of oxygen, that is equal to 2 into 1 plus 32 plus 4 into 16. 16 is atomic mass of the oxygen. So, if you add all these values, then we get 98 U. U means unified mass. In this way, we can calculate the molecular mass of the any given chemical compound. So, next one is the formula unit. The formula unit mass of a substance is sum of the atomic masses of all atoms in a formula unit of a compound. Formula unit mass is calculated in the same manner as the molecular mass. So, formula unit mass is similar to the molecular mass, because molecular mass means what? The total atomic mass of all atoms in a given molecule or in a given compound is known as molecular mass. Then what do you mean by formula unit mass? Formula unit mass is only applicable for the ionic compounds. When 2 kind of oppositely charged ions are combined with each other, forms ionic compounds. In that case only we can apply the formula unit mass. So, the only difference is that the formula unit is used for the substances whose constituents particles are ions. Example: sodium chloride. Next one, mole concept. So, mole means what? 1 mole of a substance is the amount of the substance which contains as many particles, that may be atoms or molecules or ions, etc., or entities that are equal to the atoms present in exactly 12 grams of 12C isotope. So, the number of particles, that may be atoms or molecules, present in 1 mole of any substance has fixed value of 6.022 into 10 to the power of 23. This number is also called as Avogadro constant, named in honor of the Italian scientist Amedeo Avogadro. So, next one, molar mass. Molar mass means the mass of 1 mole of substance which is expressed in grams is called its molar mass. Molecular mass of water is 18 unified mass and molar mass of water is 18 grams. Means molecular mass is expressed in unified mass U unit, but molar mass is expressed in terms of grams. So, it is the difference between molecular mass and molar mass. Molecular mass is expressed in unified mass and molar mass is expressed in grams. So, 18 unified mass water has only 1 molecule of water, but 18 grams water has 1 molecule of water, that is 6.022 into 10 to the power of 23 molecules. In this class we learned that the atomicity, valency and how we can write the chemical formula, means formula of the chemical compounds, and molecular mass, molar mass, all these things are we learned in this class. So, molecular mass means what? The total atomic weight of all atoms in a given chemical compound is known as molecular mass, and molar mass means what? Molar mass means if molecular mass is expressed in terms of grams, then it is called as molar mass. Improve your learnings, explain the process and precautions in verifying law of conservation of mass. And second one, in a class a teacher asked students to write the molecular formula of oxygen. Shamita wrote the formula as O2 and Priyanka as O. Which one is correct? State the reason. And next, third one, fill the following table. Here 5 columns are there. In first column serial number is there, in second column name is there, and third column symbol or formula, and in fourth column molar mass, and fifth column number of particles present in molar mass. Serial number 1, name oxygen atom. So, you have to write here symbol of oxygen atom, and already given that here molar mass is 16 grams and number of particles present in molar mass is 6.022 into 10 to the power of 23 oxygen atoms. Write the formula or symbol of water, and here you have to calculate the molar mass of water and write the number of water particles present in molar mass. So, for better understanding of the concepts, solve the worksheets, please visit the official website of SCERT.